Hello. Hello, how is everybody? Great. All right. My name is Rahul Farshi. I'm Chief Technologist at Zoom Data. And I'm going to talk to you today about how we take a look at interactive analysis and streaming data. And so at Zoom Data, we have a pretty unique way we think about streaming data. We want to provide an interactive experience for the analysts to go through, visualize the data, understand what's going on, look at that from multiple different areas of context. So what does that mean for Zoom Data? So it means visualizations need to react, they need to be responsive, they need to adjust to incoming data. It means that customers want to be able to start, stop, pause. If data is coming in flight, it's coming in at a velocity, they want to tone that down. They may want to move to a particular period in time. All of that kind of capability has its own unique implications from a technology perspective. So what I'm going to talk to you about today is how one of the ways that we're looking at utilizing Spark Streaming and Spark to help us accomplish that. So we've set off a little over 3 or 4 months ago on this kind of evangelical way of revising our method of handling Sparks, of handling streams and stream processing, all to kind of support this use case. So before I get into too much of the technology, just want to go through and maybe get a feel for the audience. Like, how many people are working with streaming data today? Okay, good many. How many people are trying to visualize that data and work with that? All right, awesome. So at Zoom Data, all of our customers are trying to address streaming data. They're also trying to address data that's coming in different periods from different areas. They want to be able to work with data. They want to be able to get at the data without having to wait for an ETL job or some other process to run. So they're looking at stream processing engines to help assist with that. But that's merely just like landing the data and making it available. They want to also be able to work and understand that data quickly. So just a show of hands, how many folks have built a visualization off of a stream source and maybe just, a number of fingers, like how long did that take in terms of number of days, number of man hours, anything like that? We're usually talking days, weeks, kind of things to produce an analytic. And so that time to analytic is what we're looking to decrease. So when our customers go into the application, they look at data. They want to be able to start to create their dashboards right away and have all of that data available. Now, when they look at the data, how many folks are looking at purely just the stream? They don't need to look at any other data along with that stream. Not a lot of hands. I would imagine everyone needs to look at that data in some kind of context. So to be able to look at that data in conjunction with the historical records that are there, to be able to say, okay, I want to look at a rolling hour, or I want to look at cumulative metrics over time, and I want that to be updated, and maybe I want to take action on things when they hit a threshold or something like that. So that's when we talk about adding the business context, that's what we want to be able to achieve. So what are some of the challenges with this? How many folks are dealing with streaming data coming in from multiple different time zones? So time handling is a big deal. It's challenging, it's arduous. Am I going to just default everything to UTC time and make that happen? But then what about the analyst? Are you going to force the analyst to make that mental transition from whatever their local time is and have that kind of context switch? when you think about streaming data and IoT and all of the rest of the technology buzzwords around streams, are we talking about things that can be readily visualized and absorbed by human beings? Like, how many people can really look at something going and updating every millisecond? Like, that doesn't work, right? So you need to be able to kind of adjust that frequency, right, for human beings to digest the information. When we talk about retention, so this kind of goes imply, how long do you keep a stream? Is a stream something that is just there and gone and then you're done with it? Maybe. Depends on the use case, right? So some things may be more valuable. They may have some finite time period that is where the utility of the data is like useless after an hour, right? If I haven't made a decision, if I haven't taken action in that hour, the utility of the data is gone. Some of the things need to be viewed over time and addressed in retrospect to some other historical trend. For example, in ad tech, right? You might want to understand a Thanksgiving campaign. Well, you may want to be, in the thick of it, making some adjustments on that kind of campaign analytics, going back to the previous year to understand the performance on the previous Thanksgiving campaigns is important. Then synchronization. How many folks are working with multiple streams coming in from different data sources? Few. So synchronization of those streams, getting them locked in step and available for an analyst to process, to understand what timeline that's on, or to be able to synchronize that across, maybe you're providing a single view of a customer, and so you're synchronizing that across other non-time-based kind of attributes. Those all kinds of pose challenges. Then the order. Do all events come in sequentially in the right order? That just doesn't happen. You've got events that are coming in off of different streams. You've got them coming in different orders, and you have to make some account for that. You've got maybe the event time. You've got perhaps the time that it landed into your stream processing engine. You've got the time it perhaps landed on your data store or your sink. And then one of the biggest issues with any kind of stream or data movement is restatements. So is every item or every event unique and individual? Or am I getting in the data some update to an existing event, and I need to be able to handle that and deal with that appropriately? These are some of the challenges that we have to deal with at Zoom Data with regard to streaming. So we process stream data today. We do a lot with that. We started off with a historical stack of technology, kind of pretty standard stuff, JMS queues, working on manipulating the stream in memory. We were landing that data into MongoDB and then interacting with it. We've got a custom code approach to do that. But what we started to see with a number of our different customers that really wanted us to push the boundaries of scale. So they want us to handle not hundreds of thousands of events per second, but millions of events per second. They want to be able to scale out to quite aggressive numbers. And they want that cushion, right? So a whole number of set of different use cases, new use cases, customers traversing an uncharted space. And what we started to see were a number of different patterns emerge in implementation. And so when we started to see that, we noticed there were 4 main things people were doing and we needed to be able to address. One is we need to be able to receive the data, and we need to be able to do that in a scalable way. We need to be able to manipulate the stream to do things like aggregate it up to a level where a human can interpret and understand the results. We need to be able to hold that data into some kind of residual memory. And so that took many, many different shapes and forms depending upon what the customer had. Some customers have their Hadoop stack and are landing data into HBase or other things like that. Cassandra is another very popular sink for these things. But the diversity around there was large. And so one of the things that they needed to do off of that then was interact with the data. And that's where we kind of come in from the Zoom data perspective on providing that interactive layer. So when we started to see these, we have had a lot of customer requests for us to be able to handle that stream, right? So if you want to implement Kafka with Spark Streaming, land it into Cassandra, and visualize off of that, it's a lot of work. It's much easier than it used to be, but it's quite a undertaking. So like most good customers, our customers ask for the easy button, and they want that kind of ease of use all around. So what we started to do is introduce a new technology cast and crew to help us handle this problem. We know we need to handle streams from Kafka. We already handle Kinesis and to some extent JMS queues. We'll get to that in a little bit. Processing fabric. So what we have started to do is incorporate Spark Streaming as a processing fabric for our stream processing engine. And then a landing area. And so landing areas can take many different shapes and forms. For Zoom data, we need something that we can do interactive query on. And this helps us bridge the gap between holding things for this retention period in a residual data store, or keeping those things in history indefinitely, right? Like you can have an existing historical store. You can have your streams landing to that. You can then we've got a little bit of secret sauce to kind of go back and forth in between the what's in your real-time window and then what's in your historical stream. So here's how it looks. What we've done is we've implemented a streaming server. It's basically a microservice that helps us define and submit a job to Spark Streaming. And what that does for us is it holds our context so we can inspect what's going on with that. And it gives us some facade to expose to the rest of our application that makes it a more uniform experience for our app to query and inspect the data. So we generally take streaming data off of Kafka as parsing that topic, bring that data into Spark Streaming. We've got some configurability on adjusting that aggregation window. So am I looking at things every second and bubbling that up to a per second record and performing those aggregations? Am I looking at things every 5 seconds? Make that variable. And then for the sake of explanation here, we can land that data into a number of different sources. So what's depicted on the diagram here are two sources, MemSQL and Solr. We'll point to kind of why later on in the presentation, but in this case, a landing area of MemSQL is fine. It could be other sources, as long as it can kind of perform on that interactive query perspective. And then Solr, in the case if you had full text or if you had any kind of unstructured data. And what this also gives us is this kind of common route to land that data. So if we've got this singular RDD construct where we've got the Spark streaming RDDs in there, we can ensure some level of consistency across the data sources we land to when we kind of fork that out of the Spark streaming process. So here's how this kind of picture looks with the rest of the Zoom Data application. So we've got our regular Zoom Data application. It interacts with the streaming server to set up a source, and then it also interacts with that streaming server to query what we're representing to Zoom Data as the stream. And in this model, we're able to have some intelligent routing within the streaming server, whether to pick up data from this landing area or retention area in, like, say, MemSQL, or project that data right out of the RDDs. So back to scale, right? So why did we embark on this kind of adventure in Spark streaming, and why are we kind of doing this? So the whole objective of this was to be able to scale out. So we have the ability to scale on ingestion with Kafka, and that scalable infrastructure to horizontally scale out receipt and holding of that stream. We've got a scalable infrastructure with Spark streaming to really tackle and process and meet certain objectives in terms of transactions per second or events per second processing. We've got different pluggable and scalable landing areas. So we can point this stream to land into a multiple of different areas. And then the key thing here, though, as a visualization engine is the users, right? So we need to be able to scale, like, on the user load, on the user counts, and everything else. So that's where the streaming server comes in to help us scale on that perspective. So I want to take you through a little demo of how this looks within our application. What you'll see here is a Twitter producer, a Spark streaming job, taking and handling those tweets. And then we're landing into both a MemSQL and Solr syncs. And so the Solr syncs gives us some text analytics on the unstructured text. We're not really doing anything special there. It's purely a demo for understanding. And I think my colleague here, Kwan, who's one of our principal architects at Zoom Data, thanks, Kwan. He set that up just recently to point to the Spark Summit hashtag. So we'll see how that goes. Okay, so this should be pretty familiar for most folks. I've got some connectivity issues here, but we've got our Spark Master kind of landing page. We see we've got a couple of different Spark streaming jobs here running. So clicking on Spark Streaming East. You can see a lot of queries. And we can see the receiver, our Kafka receiver, receiving topics off of the Twitter producer and submitting those into Spark. So then how that looks in Zoom Data is we're able to produce a nice dashboard. It's really quick to add and create these visualizations when I have connectivity. And then you can see the different visualizations react and respond to tweets coming in. And I'm sure some folks in the audience may be on their Twitter right now, tweeting some things out. But also, what I want to highlight here is the ability for us to use a tool that is interacting with the stream. I'm able to pause the stream. I'm able to rewind to a point in time, back into that history, utilizing the retention area. I'm able to drill across, look into different aspects of what's going on with that. I can come back out, look at other areas. I'm interacting with this stream all live and performing those aggregations on the fly, and the visualizations are all reacting to the different events coming in. This gives me the ability to provide context. In this view, I'm looking at a cumulative kind of view. In this other view, I'm just looking at a rolling period, and I can move that and adjust that rolling window of what I'm looking at. And all of that gives me the context to do what I need to do as an analyst. I can save, I can share with my colleagues, and I can move that forward. I can even save those points in time, going back to that Thanksgiving campaign use case, right? And go back to Thanksgiving 2015, take a look at that campaign, see the performance, and then compare that with performance from this current campaign. Bless you. So, what are the benefits? What did we get out of this? So I've got contextual expressiveness. I can express what I'm trying to do in the data. I can get some context on the stream and what it means in relation to my data. I've got my independent scalability. I can scale up. I can scale around whatever problem. If I've got high user concurrency, I can scale that portion out. If I've got an influx of data on my stream, I can scale that portion out. We've got the expressiveness powered by the Spark streaming and the data frame API. I can have a uniform way to interact with my data with the RDDs, and that provides me a lot of benefit from the development perspective. And then because we have a pluggable landing area, right? Like we're landing and we're holding that retention period, we can also address like enterprise constraints around DR and COOP and whatnot with the stream, right? That's always a challenge to address this, not as a science experiment, but in the enterprise. So we're not done yet. This is in the works. We've got a lot of work ahead of us to do, tackling some things with stream synchronization and fusion, the ability to augment the stream with additional information, additional attributes. We're looking at on-demand scale-out, so we've had a lot of requests of providing elastic scale infrastructure, and we're looking at how we've had some early success using Mesos for that. And then, the age-old problem of handling schema evolution. We handle it today with our current method. We're kind of cheating a little bit because we have MongoDB and kind of this NoSQL model to append additional attributes. So we've got some new strategies for that. And then more extensible landing strategies, because we do see so much diversity of where people are landing their data and how they're kind of preserving that stream or that history. Thank you.
Cool. Thanks very much for this awesome presentation. We do have 5 minutes for questions, so if you've got any questions, please raise your hand, and I will try to hobble over there. Okay. Go ahead.
Hey, thanks.
Hi.
So how does the going back in time, like selecting a given subinterval and showing the statistics only for it work? Do you like reprocess the stream? Or?
No, we're not reposting the stream, so we're keeping that retention area. And so we're going back to that data source that's holding that retention area. Now, one of the things that we do with that, though, is if we get streams with things like restatements. So many times we'll get things where it's like, no, all of that stuff is wrong, we need to replace it. Gives us that flexibility to do that.
You showed the dashboard, right? Will it work with the off-the-shelf stuff like Tableau and all, or just as a proprietaries or part of the your
So-
product?
So Zoom Data, this is our own application. We do have quite a bit of extensibility in the UI. So you can create your own visualizations using JavaScript and HTML and hook them into our data engine and get the utilization of that stream processing that we provide.
Cool. Any other questions?
Cool.
Oh, okay.
Can you share your thoughts on cross-stream synchronization?
I can. I think it will take a little bit long to explain. We do have a booth here at Spark Summit, and I'll be there to have a more in-depth conversation on that. But the gist is cross-stream synchronization requires a number of different items to be there. Our biggest issue with that is what to do when there's not really any other time attribute than the time that the event was fired off. So I can talk to a little bit more into what we're experiencing with cross-stream synchronization further.
Cool. Makes sense. What booth number are you again? Do you remember?
Booth number. We're there. We're at the expo center.
Okay, well, they're in the expo hall. Okay, cool.
All right.
There's a question? All right, perfect.
Can you comment on the performance of the landing area? Because how you choose the SQL because besides SQL, main SQL, the other landing area like say, like your Cassandras or Edgebase, any other sources. So why you pick the one of you showing?
So our objective is to be pluggable, and we are pluggable with many different landing areas. We've done Solr, we've done MemSQL, we've done Cloudera Kudu. You know, the main thing is like we want to provide flexibility for our users and our customers to choose the platform that's right for them. They may have existing investments in existing platforms, or they may have scalability targets that require a pretty specific choice. And we've had pretty good success with landing in multiple different areas and ratcheting that up to hundreds of thousands of transactions per second now, and looking into like the 7-figure transaction per second benchmarks.
Cool. Any other questions?
We're in booth 108.
Cool. Thank you. Sorry, any other questions? If I don't see you waving your hands, I apologize. All right, cool. Well, then I think that's about it. Thanks very much.
Thank you.